Woo. Got it. Exactly. We have a little feedback on this though. Let me see. How do I mute? Is this muted?
It's muted. This is muted. This,
The speakers are.
it's muted. It's muted.
Yeah, no, it's the speakers I'm hearing this sound coming back out.
Try that.
Okay, is that down? Yeah, that's better. Okay, great. Okay, welcome. Thank you. This is our October NCGS meeting. Okay, you're gonna use that for the speaker too? Camera?
Sure.
You do that? Okay. It's not gonna be me for long. So, okay, we're gonna get started with the meeting. Jim O'Brien, I'm the president. Just a couple of quick remarks. The registration system we're using now that Don Medwood have set up, I think is working well. We did have some questions about whether everybody got their newsletter. So if you didn't, please let us know so we can check to see why that didn't go through. But the newsletter feed that's coming now is actually an email with a list of highlights that Mark Sorensen has put together for the month. And then a little link that you have to click to go to the website that actually has the newsletter on it that you can download and print. So if you're not finding it, let us know. We'll see if we can help you with that. So I mentioned last month that I set up a NCGS at YouTube channel. So it's actually listed as at NCGS 1000. That's the name of the YouTube channel. And if you just search for that in your Google YouTube, you'll find a series of talks. So all the talks from last year were downloaded or uploaded, and they're up on the YouTube cloud now. And after this meeting tonight, we will take this talk and do the same thing so people can look at it after the meeting if they're not here. So, okay, that's all I have to say in terms of NCGS business, but I know we normally have a number of announcements. So, Will, I know you have to leave early. Do you want to say something right now about field trips?
No, we're in the process of doing the upfront work for a spring Eagle Island trip. That'll be very interesting. And I know nothing about the geology thereof.
There you go.
It's in progress. There's going to be a crew of potential leaders that are going to do a field trip with
Christy Rowe. Yeah.
So anyway, thank you all.
Very good. Thank you. Okay. Who else? I know Phil, you have something about the scholarships?
The NCGS here offers 2 scholarships, $2,000 each to graduate students doing research in geology or related fields in geology. Northern California. Is this one working? This one. If you know a student working in geology it doesn't have to be a person in Northern California, but the project should be somewhere in Northern California or close to Northern California. This has been sent to all schools in Northern California that have graduate programs and several university schools that do not have graduate programs. So that people are aware of it. So if you know somebody particularly that's looking for money, tell them to just go on the NCGS website and they'll find the information. Now, back in the back table, you see a bunch of books. Besides the guidebooks, the other books were a donation to the NCGS by a former member. I had about 10 boxes and I've been bringing the loads in, and it's you pay what you think the book is worth and go home with it. I'm going to bring one more load in next month, and then I'm going to sort through what remains and decide whether they're going to come here or whether they're just going to disappear. But I've been doing this since all fall, and I think earlier in summer, before the summer. So you've had a chance to look through them. They're good books. Take them home with you.
Thank you. Okay. Let's see. Don, did you have anything to say?
I would probably just add to your comment on the
To the mic. So it gets recorded. Yeah.
I would add to the comment on the emailing. Is that the right mic? Emailing of the newsletter. it's not really my job, but anyway, I'm sending out the newsletter via this web-based system. I can see that, 285 emails go out. I think I just saw there were 160 people open to the email. So I know there's 125 people that didn't open it. I don't know if that's because they didn't get it, their spam filters taking it, or I have no idea. The newsletter is mailed from with a real address of no reply at, I can't remember the details. And then in the subject line, it says NCGS editor Mark Sorensen or vice versa. So if you searched on NCGS and it's in your system, you should find it. If you're not finding it, I'm guessing it's because your spam filter is catching it either because it has a link in it or it's coming from somebody that you have a setting that doesn't accept things from people you don't know, or I don't know what, but I'm not getting any feedback as to what's getting rejected. So I have no idea of the, whatever I just said, 125 people who are not opening it, whether they're just not getting it. And some of those people aren't even people. Some of the addresses are not people. They're geology clubs and whatnot. So I don't even know if they're still valid, but anyway. So if your point is, I'll get to the point. The point is, if you're not getting the email, send me donmedwoodf@gmail.com a notice. I'm not sure what I can do about it other than if there's enough people not getting it, I'm going to kick it up to Jim and say, fine, to do this.
Gotta love a guy that delegates upwards. Okay, let's see. Andrew, I think you had a few things to say about the website, right?
Yeah, but Don's address is in the newsletter.
But you gotta get the
So if you didn't get the newsletter, then anyway. I have finished revamping the NCGS website. It doesn't look as pretty as it used to be, but it's fast, it's simple, and it's got a bunch of improvements because I've been linking stuff. So the history of the website was created in 2003 by Art Bonwell. Any of you remember him? I do not believe I ever met him. And then Mark Detterman was the webmaster from roughly 2005 until 2018. And then Jonathan Parch was webmaster for a couple of years, and he was responsible for getting our previous design with the big fancy photo and so on. And I had to simplify that because I simply couldn't work backstage with it. So I recreated it. I have revamped every page. I have refreshed all the text on each page. And I have renamed all the files in the background, so they're not just weird random names anymore. That's like 800 different photos and text and PDFs and so on. And while I was doing that, I had a chance to revisit some of our old field trip reports, which are online. And in particular, one I'm proud of was our expedition to the Coso geothermal facility which is inside a naval weapons base. And of course, we had permission for a couple of tiny little images that Ann Sanchini made. But I thought, we did other stuff before and after, and I have a bunch of photos, so I added those to that. So if you want to look up that old field trip, check it out. I have everything's updated. Please explore the site, poke around, follow the links, and I'm hoping for the old timers in the audience that you'll ransack your shelves and look for old field trip guides which have not yet been digitized. Look at even if you contributed photos to an old field trip report, they were just tiny little images because back then in 2003 we were all worried about bandwidth. Images had to be just a couple 100 pixels, and if you want to revisit those and submit good robust images, get in touch with me. Like I say, I'm in the newsletter too. Thanks.
Here you go. Thank you, Andrew.
It's a lot of work.
One other thanks, I actually sat in for Paul Henshaw this afternoon for a little bit on the the Pacific section of the AAPG. My first time with this group, a little disorganized, but they actually started out by thanking NCGS for our continued movement of candidates to them for awards, because this is one of the topics on the agenda. So thanks to Don Lewis and to Paul, and I don't know who else has been involved with doing this over the last several years, but we're on their radar, which is good. So thank you. Okay, I'm going to turn this over to our program director. Paul Henshaw is one of three, and he's responsible for tonight's program. So Paul, take it away.
I have a really long bio and abstract that I'm not gonna read. Oh, I have a really long abstract. Well, no, let's leave it at her height. She's gonna go. Okay. Tasting, 1, 2, 3. Okay. Okay. So Linda, Diz, whatever she's called, everyone in here probably has a different name for her. But I've known her for quite a while, and it's been a very interesting past. But it's even more interesting if you read the bio. And the main things part of her life, she started off college, Peace Corps, then she started writing geology articles. And then she went in, she really loved igneous petrology, right? Petrography, petrology, yeah. And she got into the oil business through the minerals group before oil companies realized that they didn't know anything about minerals and how hard it was to do minerals. So then she transferred into what we call the oil business. And that's where I first met her. And another interesting fact is she was married to Charlie Swift. I don't know how many know that. But he's one of the few people that ever read my thesis. So we had a great time. He was very nice. It was paleomagnetics, magnetics, and all that kind of stuff. And he was a geophysicist and I was a geochemist. So it was quite interesting. And then I met Linda, Diz, as I was moving out in the opcos and coming back to the research unit. She was moving from the minerals group into the research group, and she'd been in and out of that. And another interesting part of her history is she worked for me, then I worked for her. So it all worked out as, you know, as far as people being transferred, new organizations. And I just found out that Chevron has bought Hess Oil, which is great. That's what I want to talk to you about. And today she's going to talk about one of the things that's probably on all our minds. And the thing I really like about that is, look at this, see that word possible in there? You know, if this was cleared by Newsom, it would say, and tipping points. And they're all going to happen unless you vote for him. So she will go through some of the tipping points that maybe are more realistic and have some time in them, whether it's 10 years, 50 years, or 1,000,000 years, because it's all very complicated and it's very exciting. And those of you that used to like the ocean, think of that, bigger waves, surf is up, or could be, okay? And so she will be going through a lot of information and trying to give us a taste of what some of the realities are. Her background is very diverse, everything from working in the Tierra del Fuego, glaciers, igneous rocks, minerals, and most recently in climate. And what you'll realize with climate change is it's involved with everything you can think of. And the other thing that scares me to death is somebody's trying to make AI models out of this stuff, and they know maybe a third of what, or a tenth of what may be involved. So let's listen to Linda, give her a hand, and vote for climate.
Okay, so how do you do this? He promised, but he left. Oh, there we go. Here we are. We're good. So thank you all for coming, and thank you, Paul, for that introduction. His point that climate affects everything is absolutely right. And the timescales are widely different. And we're in uncharted territory. So we're in a place now that we haven't seen, we don't have any analogs for. So there's a lot of unknowns in climate. What I have put together is in an hour, you can't cover climate change. So I have put together what were the most compelling arguments I found when I first started looking at it and as I have worked through it. So speaking to a geologic crowd, you will see some geologic references here. So the first thing is, yep, it's getting warmer. It's getting warmer and it's getting warmer fast. These are summer temperatures from the 50s to the 80s. And these are more recent temperatures. The important, you can see the shift, but the extremely hot is going out very far. So yep, it's getting warmer and those are data. These are data and an extrapolation showing the trend to 1.5 over the 1950s range temperatures. The August temperature was 1.5 degrees Celsius warmer than the pre-industrial level. That's this point right here. That was 2 months ago. We're already there, guys. And the extrapolation takes us out to December 2034 if you just extrapolate. There's no reason to think that we won't continue on this path because we haven't really changed much, as you'll see. Greenhouse gases, which is GHG, emissions are not slowing. This is from Mauna Loa Observatory, just keeps going right on up. It is now at 412. That was a month ago or so. I don't know what it is very much today. 412 parts per million. Remember that number. Methane, which is a more potent greenhouse gas, and we'll talk a little more about that, is also continuing up. In fact, it's sort of concave upward. Greenhouse gases are all not alike. And it's important to understand the difference between them. Carbon dioxide is by far the most important. Its period in the atmosphere is from 50 to 200 years. And the global warming potential is set arbitrarily at 1, and everything else is compared to it. The primary sources, big one, is fossil fuel use, and less so land use and cement. Methane is shorter lived and it oxidizes to CO2. 21, and it can get up to 80 depending on the time frame, more potent than CO2, and mostly fossil fuel use and agriculture. You've heard about the cows. Nitrous oxide, 120 years, 310 times more potent, and it also is mostly agriculture. And about a third of that is anthropogenic. Then we come into these critters. These have the high global warming potential gases. They're very, very powerful. Not very plentiful, but very powerful. So hydrofluorocarbons, lifetime about the same as CO2, but the global warming potential is huge. We'll talk, this is the alternatives to ozone depleting chemicals. Perfluorocarbons, we won't spend much time on, and you'll see why in a minute. And sulfur hexafluoride, which is a nasty critter, 3,000 years in the atmosphere, and almost 24,000 times more potent than CO2. It is used in electrical power transmission, and we'll talk about that in a minute. Carbon dioxide is increasing. Methane is increasing, we just saw. Nitrous oxide is about stable. Hydrofluorocarbons are increasing. Perfluorocarbons are actually decreasing, yay. Sulfur hexafluoride is increasing, and it's increasing a lot. This is sulfur hexafluoride data from NOAA showing the increase. This is something that stays in the atmosphere for 3,200 years and is very potent. Why is this increasing? Interestingly, this is used in transmission lines, grids, and the developing world is starting to build these grids, and they are drawing and demanding sulfur hexafluoride. So the increase in use of sulfur hexafluoride is largely from the developing world. So geologically, we're all geologists. We know that this is not a big deal, although it really is, and we'll talk about that too. This is temperature change and time, KT boundary. And at 56 million years ago, we had the Paleocene-Eocene thermal maximum. We'll talk about that in a minute. And then from then on, we cooled. Whoops. Paleocene-Eocene thermal maximum you may have heard of, 56 million years ago. CO2 was at about 1,000 ppm. We're right now at 412. 4 to 8 degrees Celsius warmer. There were no glaciers. Sea level was 250 to 300 feet higher. That would flood downtown Berkeley. And the Arctic Ocean temperature was 70 degrees Fahrenheit. Nice swimming. Now, this didn't happen overnight. So we can't say if we're at 1,000 ppm, suddenly the oceans are going to be that high. It takes time. But we're on track for that. That was 1,000 ppm. This is an MIT projection they did in 2013. And based on this, we'll get to 1,000 ppm by 2110, 2100, 20, whatever. We're on track for it. We're on track for it. Look at the ice. This to me was very compelling. These are ice core data from the Vostok area, which is the thickest part of the eastern Antarctic ice sheet. And from present to 800,000 years, CO2 was and methane were actually measured in the bubbles, the concentration, and temperature was data was based on the original deuterium data and interpolated to a 500-year resolution. So it's within that resolution. First, look at the correlation. I mean, everything correlates very well on all of them. So we know that it correlates. One thing to notice is that through this period, Homo sapiens are only there for about half of that period. So we haven't, I mean, Homo habilis and so on were before that, but Homo sapiens were just in about half of that time period. Notice that in this time period, CO2 never got above 300 parts per million. And methane never got above 800 parts per billion. That's where we are today. (800 to 1920, 300 to 412. And this is vertical on this time scale. It's happened in a geologic sense. I can't say instantly, but really fast. So we're in uncharted territory here. This is a very fast change. This was is a chart from the 2007 fourth report of the Intergovernmental Panel on Climate Change. When I saw this, it was really something that was compelling to me, so I wanted to share it with you. It shows radiative forcing relative to zero. Radiative forcing to the right means that it makes things hotter. To the left, it makes things cooler. CO2 alone has a strong radiative forcing. This is at the concentrations of 2007. Methane and then the halocarbons, you know, the high global warming potential ones, although they're very, very small amounts, have a very large effect. I want to draw your attention to the negatives. These are from aerosols. Aerosols are little tiny particles. Those who understand aerosols will probably cringe at my saying it that way, but like smoke, has aerosols, and the direct effect, which is the top one, is shading. So when you have smoke, you limit the sunshine and it cools. The aerosols also provide a nucleus for water droplets and form clouds. And so that's the cloud effect. Interestingly, aerosol nuclei in cloud formation cause the clouds to be very white, which makes them very effective at reflecting. The net is positive, but you take this away, which if we take away some of the smoke and some of the combustion of fossil fuels, we take away aerosols, those go away in weeks. These go away in centuries. So we have a strong effect here of positive anthropogenic radiative forcing. This in the 2007, this was solar irradiance, very, very small relative to the anthropogenic effects. Fossil fuels are the major reason for the CO2. It's fossil fuel combustion. This shows the US consumption of fossil fuels and the global, actually total energy consumption, which is mostly fossil fuels. The blue is the temperature. This is correlation, not causation, but by golly, it's convincing. Fossil fuels can be replaced with, especially liquid. Coal can be replaced with natural gas. Natural gas is less harmful than liquid fossil fuels, but replacing liquid fossil fuels, especially gasoline and diesel, which have a very high energy content, is very difficult. And everybody wants a car. We have an insatiable thirst for liquid fossil fuels. And I love this slide. It was a 9-day, 60-mile traffic jam. Whoa. And that was 2010. I don't know what they're doing now. So are humans to blame? This is natural. There are many other things, but this is a predominant one. And all the others are anthropogenic. This is a chart that was there's a lot of data that shows that human fossil fuels predominantly, but humans of the high global warming potential gases, as well as methane and nitrous oxide, are predominantly from human actions. But this is a cool chart for me anyway. This is C14. And as you know, C14 decays. So it goes about to zero in 100,000 years. How many know an oil reservoir that's younger than 100,000 years? None. maybe, I don't know of any, but very, very, very few. And so the decay or drop in C14 shows that we're combusting original fuel that is older than that. And that's compelling to me.
Is this from the average atmosphere?
No, it's from the clean air measurements at one place. So some of the data, you've all been reading the news about how hot it was this year, and it was. But on a longer scale, the oceans, which are the most important savior for us, really, have been warming. This is near surface and this is lower. And that's from 95 to 2020. And this piece of data that 90% of the warming has been taken up by the oceans. So we're not seeing a lot of the warming because it's going into the oceans. These are data from over a number of years that you can see different colors. And here you can see from green, older, to red, more recent, that this in the Florida Keys, this is in North Atlantic. In the Florida Keys, this is what happened to July. This is the North Atlantic, way out of line. with what's been going on. I didn't put it on the slide because I thought it was just too extreme, but at Manatee Bay in the Florida Keys in July, a buoy reading of the ocean surface temperature was 101 degrees Fahrenheit. The warming, of course, is causing ice sheet loss, and that's dramatic. This is 2002 to modern day, and the dark colors show you where we're losing ice in Greenland and in Antarctica, mostly in this area here in Antarctica. Compare ice loss in Antarctica is less than in Greenland, which surprised me, actually. I didn't realize 271 gigatons to 147 gigatons. These are floating ice masses, and they are accelerating as well. Of course, floating ice doesn't raise sea level because it's already in the water, but they do hold back the ice behind it. The serious melting is, as we showed you, is in that one area. This is the Thwaites, the Pine Island Glacier here, and the Thwaites Glacier. They were grounded. They were frozen to the bottom of the ocean, basically, but it's all uphill behind that. And they have become ungrounded. They've melted enough and the water's coming in underneath. So they're floating now at the edge and it's all uphill. So they're flowing into the ocean. And according to Rignol, who is, if you don't know him, he's a very, very, very well-known glaciologist who's done a huge amount of work in this area, says that they're basically unstoppable. Pine Island Glacier here, the scale, that's about 60 kilometers wide. These are giant. These glaciers alone, just the one shown in red, can raise sea level 1.2 meters. The warming is not distributed evenly across the globe. These are data from NASA showing temperature. Blues are cooler, reds are warmer. Through time, 1884, 1950, 95, 2012, it continues to look more red to 2023. But this shows the point I want to make, that it's warming most in the Arctic. Don't ask me why. But the data show clearly that that is true. And that's a problem. The melting of Arctic ice is a problem for a couple of reasons. This is the March maximum and the September minimum, and they're dropping down, and this has continued. These are data from 2012 again, but it's continued with this trend. When the ice melts, the ice has a high albedo, it reflects the sun, it's cooling the area. If there's meltwater on the surface of the ice, it's dark blue and it absorbs heat. So the entire heat budget increases. And so you have more and more melting. Losing that sea ice is a dramatic effect on the Arctic area. One of the things that you have in the permafrost are called methane hydrates, clathrates. This is a picture of a hydrate. I thought it was this University of Göttingen. The red and white are solid water ice, and in the middle is a methane molecule. When the ice melts, methane is released. This is burning ice. That's ice, but it's releasing the methane, and so it's burning. You go online and look up Arctic burning ice or lake ice burning, and you chop a hole in the ice of a lake, and because the hydrates have melted, there's a concentration of methane, and whoosh, you get a big flame. So it's happening now. This is serious. Permafrost underlies, this is an image looking down on the North Pole. The purple, largely in Russia, but also in North America. Huge, huge area, 8.8 million square miles are underlain by permafrost. And once we start to release that, we can't turn it around. It's irreversible at a human scale. And as you release more methane, more heat, more methane released, more heat, etc. This is a tipping point we'll talk about, but this is the one that I think is the most serious. What is going on? Methane hydrates also occur along continental shelves if the temperature is sufficiently low and the pressure is sufficiently high. These are seeps of methane hydrate shown in these little arrows or little dots, deeper than 600 meters in red and on the shelf in green. And these are actually seeps of methane. The important thing to note about this is that if methane is released at greater than 600 meters, it will dissolve in the water column, or it can be oxidized to carbon dioxide, so it's not released to the atmosphere. So it's not the same level of problem that you have in permafrost. But if it's less than 600 meters, it can get up into the atmosphere. A downside is that if it's oxidized to CO2, it takes oxygen out of the water and can lead to dead zones. What happens with warming? We're already seeing warming. What are the things that we can look forward to? Changing weather patterns we've heard a lot about. Drought, stronger storms, wildfires, and so forth. But others that are very important are also agricultural disruption, migrations of animals of all kinds, including humans, sea level rise, loss of biodiversity, changing economy, pressures on the economy, and it's a defense threat multiplier. Our Defense Department has recognized this for decades. Changing weather patterns, talk about that. You know about it, the atmospheric river, floods, drought, wildfires, stronger and stronger hurricanes, agricultural disruption. Growing seasons are changing. When does it start? When does it end? The stone fruit like peaches need cold winters. And if you don't have a cold enough winter, you can't get peaches. So I'm told by stone fruit growers. Changing weather patterns. When is it going to rain? When is it not? And of course, drought and flooding. This is not well understood, how agriculture will be disrupted. This is not well understood, but it's being looked at seriously. More and more people are doing serious research in all of these areas. So we'll learn a lot soon, I hope. These are two quotes, though, I thought were worth looking at, that the risks of low yields are underestimated in what we've looked at so far, and we're likely to face major disruption in food supplies well before 1.5, and we're almost to 1.5. Migration, human migration, bird migration, animal migration. Because of heat waves, drought, you can't live where you don't have water, heavy precipitation events, too much water, agricultural disruption, stronger cyclones, sea levels, thawing permafrost in the far north. Houses are falling down because of the thawing permafrost, not so much the hydrates as the change in landform. And all of this leads to political unrest. And we're seeing that more and more. Migration from Central America can be tracked right back to climate change and loss of crop. Sea level rise. This is US. It's way worse in Bangladesh and of course Micronesia, where you're losing the entire country. But this shows a population at risk, and no surprise where it's big problems. These are the dark orange is 100 to 200,000 people more or less in those areas. But it's interesting that it's all the way up the Atlantic coast. And that is with not even a meter of sea level rise by 2100. And most people see it as 1 meter, no, 2 meters plus or minus a meter by 2100. So this is a low estimate. Biodiversity, we are dropping. World has seen an average of 68% drop in animals since 1970. Most of that was habitat destruction, but it's increasingly climate change as climate also begins to destroy habitat. Talk about economics. Insurance companies have recognized this for a while, and now they're really getting serious. They were worried for a couple decades, and now they're serious. Sea level rise and storms in the Atlantic seaboard are causing the insurance companies to not cover hurricane damage or storm surge. A comment, rising seas threaten an American institution, the 30-year mortgage. If you can't get insurance, you can't get a mortgage. In California, last year, State Farm and Allstate, two giants, said they won't write any new homeowners insurance in fire-prone areas. And this year, at Amgard and Falls Lake said they won't renew existing insurance. So backing away, insurance companies are seeing that this is really a problem. So these are the results of warming, and they're serious. So we'll talk now about the tipping points, which warming as an insidious gradual change is one thing, but some of these could really make a bigger difference in a faster time frame. Accelerating ice loss. We talked about ice loss in these areas. These are data from the Arctic and the Antarctic. The red is the minimum. So that was in the Arctic in 2012 in the autumn, but in the spring it was 2023 was at the minimum, and 2023 is near the minimum in the Arctic. In the Antarctic, 2023 is the minimum. So ice loss is accelerating. And especially in the Arctic, that is the problem, that we're losing the cold, and the permafrost melting is a tipping point. Once it starts going, you can't stop it. And it's beginning to go. Another are changing currents. A partial collapse or a slowing of the AMOC, Atlantic Meridional Overturning Circulation, which is shown in the picture, which brings warm water north and cold water south. It's a thermohaline current driven by salt density and temperature density differences. And one thing to note, this is an important piece. I always thought it was the Gulf Stream. It isn't. Gulf Stream is something that's near surface, and it's mostly driven by winds. But both of them will cause a change of temperature in Northern Europe. This article was published this year and caused a lot of hoopla. There was a lot of press about it. Oh my goodness, it will collapse. We don't know that it will collapse, but it will. And what is partial collapse? I don't know, but slowing certainly. And they predict with high confidence that this tipping, that it would begin to collapse or slow dramatically by the mid-century. 95% confidence range before 2095, which is quite dramatic. If we slow that, if this is a model, these are two IPCC models. This is a high warming model on the right, and what they think is the best estimate on the left. Both of them cause a cold blob, if you will, near Greenland, which has a very strong effect on global climate. So what do we do?
Pretty simple.
What are the obstacles to action? Money, costs money. The energy transition costs money, but it will cost more money if we delay. The costs of climate change are enormous. And the longer we put it off, the worse climate change will be and the more it will cost. Politics. Politics is something that in the US is a major obstacle to action. Fossil fuel dominance. Fossil fuels, how many people here drove in a car with fossil fuel tonight, you know? We rely on it. The demand is there. It's not, I mean, we won't say whose fault it was, but we have a high demand for fossil fuels, and we can't just drop that. We have to change it so that we keep the economy running. But that has become political. Societal norms, especially in developed countries, we like a lot of stuff. Have you been to like Target or something lately? And as you check out, there's a whole rack of plastic stuff that you can buy. We don't need all that stuff, but it's part of our society at this point. And developing countries, you saw the sulfur hexafluoride case, where the developed countries are starting to want to be, or the developing countries want to have what we have. They want to have cars. They want to have all of the wonderful things that we have. Our carbon footprint is huge relative to theirs. It's coming up. And of course, population. We are 8 billion people strong and growing by about 250,000 people a day. That's the population of Montana in 4 days.
He's from Montana.
I'm from Montana. Which one is really in the way right now that we can do something about? And that's politics. I showed you data. I didn't show you belief or anything. I showed you data. This is not made up. It's real. So pretending that climate change is not happening is putting your head in the sand. And yet that has become a political issue. And fossil fuel dominance, changing the transition is a challenge. And as in the quote here, of the 20 Congress members who received most donations from oil and gas, 17 were Republicans. Most are Republicans. The views are political. These are data from 2022 showing the average of Americans asked in the Pew Research Center. Is climate change a major threat? 54% said yes, it is. More Democrats said it and fewer Republicans said it. After 2023, 62% came out a slightly different question. Is it currently having some or a great deal of impact in their local community? But after the 2023 record heat, people are starting to really change their mind that this is maybe something important. The primary argument, if you're not denying, simply denying, but the primary argument in this group is that we can't hurt our economy. We have to have a strong economy or we're all going down the tubes. And that's a false argument. These are data from California showing our GDP, greenhouse gas emissions per GDP dropping. So GDP is growing, greenhouse gas emissions are dropping. You don't have to hurt your economy to reduce greenhouse gas emissions. That's just false. Costs are enormous, but poorly understood. These are global data showing extreme weather events. And so those are hurricanes and floods. Not very well measuring drought because drought has so many extra effects, but it's over $1.3 trillion. The Global GDP is $95 trillion, so we're like 1.5%. So it's not that huge, but it's growing. But what is the real cost? We've got changing weather patterns, and we've measured a little bit about that. But what does it cost for agricultural disruption? What does it cost for people not having enough food? What does it cost to have people displaced? And so forth. So loss of biodiversity for medicine alone. I mean, if we want to look humanly, selfishly, and the defense threat multiplier, this is with migrations, with food loss, with all of the political unrest, it's an additional cost. So Paul alluded to this in the introduction. Everything is interconnected. Everything affects everything else pretty much in climate, in the aquasphere, the atmosphere, the terrasphere, and in the political, social part of our environment. This is a case study showing how Arctic warming resulted in riots in Pakistan. There was a heat wave in Russia, and so they stopped. They had a cereal yield decline, and so they stopped exporting, which caused a global cereal shortfall. In Pakistan, they had too much rain, and that caused a cereal shortfall. And so that went down here too. There was some panic buying that could have been localized or not. And the price rise, though, went up. And there were riots in Pakistan because they couldn't get enough food. And that leads to food affordability challenges out everywhere else in the world. That's just one simple example. Everything is interconnected. And understanding those interconnections, especially from a scientific standpoint, how much does it affect the currents, for example, to consider, as Paul pointed out earlier, there's warm water coming in from the Mediterranean as well into the Atlantic. There are so many variables in climate change, and we are moving at such a speed that we haven't ever met this before. So what do? First and foremost, we need to get climate action out of politics. This is not a political question. It's not a question of belief. The data are overwhelmingly strong. And to say, AGU years ago, there were folks saying, why are people still not understanding this? And that was like 20 years ago. And we're still not understanding it completely. So education. Each of us needs to educate, whether it's your neighbor or your family, or do something like this, but get out there and share the data. These are not models, these are data. And advocate, and mostly vote. We need to have people in Congress, in the US, and in all of our government that understand the importance of this and can, in a logical way, see us through it rather than a radically way that doesn't really get where we need to go. So thoughtful patterns are so important at this stage. So now what will you do? Thank you.
Thank you very much. And it stir the pot for. Thank you to all of you that did not come here and drove, but you're using a Zoom and that uses energy. Uh-oh, there it is. I went the wrong way. It must have cooled off and got small. Okay. So that was a very good presentation, I think. It was wonderful. We had a discussion. We listened to a Berkeley presentation. Oh, we had a discussion. So I said, this is wonderful. Because the person that was coordinating the whole session would say, that was wonderful. Which didn't mean anything. Yeah, you had to be there. But what I'd like to do is thank you with a presentation, and you can help impact climate change because you can put hot water in or cold water in. But if you put cold water in, you may be releasing methane in the Arctic. Hot water, you're gonna heat it maybe with methane gas. Anyway,
I
have an
induction stove, so I don't.
I don't know how those work. How do those work? Okay, so thank you very much. And there's a lot of information out in the public sector. You can believe some of it and not others, but you might look at the data and see what it looks like and see what you think about it and whether or not the data is a 2-year look or a 1,000-year look can make a difference. And trying to correlate, you can see how difficult it would be to go between all those different impacts that can be perpetrated by or cause climate change. So we thought this would be a good topic. We're all a good group here, and we can influence a lot of people. And Linda, thank you very much. Or Diz, thank you very much. Any comments?
Questions? Thank you. Yeah, Tim.
Yes. What are the top 3 things you would do?
Tim asks, what are the top 3 things I would do? The top 3 things I am doing is educating, advocating, and influencing policy. I am working with the National League of Women Voters, leading the climate interest group, which is in all of the 50 states. And we are influencing government policy. And we're way past individual actions getting us there. We have to have government policy changes. So educating, advocating, and active in government. Yes. What do I believe about carbon tax? Getting the market to work, putting a price on carbon would have a wonderful effect. A carbon tax, there are 2 ways to have a price on carbon. One is a carbon tax or fee, and one is a cap and trade. They are both a market mechanism. Carbon tax was tried in France. I don't know if you remember the yellow vests. It didn't go well. They saw the truckers particularly saw their way of living as being taxed unrealistically. However, the European Union has had a cap and trade system for, I don't know how long, like 15, 20 years. California has cap and trade. Quebec has cap and trade. There are 7 different cap and trade systems in China. It's growing fast. And cap and trade, although it is a price on carbon, puts the emphasis on the cap. So as the price is influenced by the cap. So it's also a price. But absolutely, it would, using a market mechanism, would have a rocket fuel boost. And in a place like the US, we are capitalistic, that will have the strongest effect. And it worked really well in reducing ozone. That's how it was, and NOx and SOx. Over here, I think.
Are you familiar with the California green fuels or low carbon fuels law, and what is it based on? How is it?
I don't know. He asked, what do I know about low carbon fuels? Low carbon fuels is something that California state has to reduce the amount of CO, use fuels that you reduce the amount of CO2 on combustion. Well, yeah. Yeah.
Carbon offset. Some fuels in California, you have to target a fuel amount being offset by buying carbon credits. Is that not?
Carbon offsets are more used for cap and trade. So if you can't meet the cap, and somebody else made the cap down here, they can sell that difference to you as an offset. So that's where offsets, as I understand them, are more, and carbon credits are critical in making the Amazon forest growing worth more than the Amazon forest cut down. Yes.
In your opinion, how much of a problem are the emissions from creation of things like electric cars? Are they showing it's worthwhile so far?
We used to think that oh, I'm sorry, how impactful is on carbon emissions is the use of electric cars? Is that stated well? And we used to think that electric cars were the single best thing you could do, certainly in the US. And I have an electric car, by the way. I love it. I recommend them. They're really fast, but they're heavy. And so I use more tires, and tire particulates are one of the biggest pollutants in the ocean. Surprise. I didn't know that previously. So everything. Well, and to continue on that, where you get the electricity matters. I have solar panels. If you're in middle of the country, you probably have coal-fired plants. And so that's not helping. It costs energy, however it's supplied to make the car. It costs energy to dispose of the car. So in all cases, we need the birth to death idea of how much carbon emission is caused. We can't just say this part, see how good it is over here, and that's great. Your point is absolutely well taken, that you have to look at the entire lifespan to know if it's good or not. Yes.
I spent week in Kenya, month in Kenya, where they spend 60% of their resource energy in renewable. The problem was these renewables are very nice. And one of the reasons for that was storage.
They're not what? I didn't. Oh.
No storage. And they are way storage of the energy produced by the wind, by the sun, so that people can use them at night. Because in third world countries, instead of building infrastructures for electricity, renewable energy, they could be.
So with renewable energy, you need storage as well. Is that what you're saying?
Yeah.
Absolutely. And there's many, many, many kinds of storage, not just batteries. So yeah, we need to work on that. No question. And it's not just it's here too. It's everywhere. We need more storage. And in California, particularly, we have really done well with solar. And so in the middle of the day, we have abundant power, but we don't at the shoulders in the night. It's called the duck curve, if you've ever seen it. It's very cute. Other questions? Yeah.
You talked about that particular chemical involved with transmission, creating transmission. Are there other alternatives being developed?
Don't know. I don't know. Oh, he asked, I'm sorry, I'm not good at repeating questions. Well, there are, okay, we are working, his question is, are there alternatives? We did it with ozone. You know, we can find other alternatives. Hydrofluorocarbons are the replacement for what we use for ozone. But anyway, yeah, absolutely. I mean, there's a lot of research, basic research being done on all these areas and making headway, but we're tiny a little bit there and we have a long way to go. But heartily, yay, we are waking up and moving in the direction. Yeah.
how about carbon sequestration? The opposite of all, and there are also ideas about fertilizing the oceans with iron to sink more carbon and sediments also. So the larger geoengineering schemes have in particular, and they make a difference if that.
So the question about carbon sequestration and other ways to capture and sequester carbon, not just carbon sequestration that we're most familiar with, which is in the oil patch of CCUS, carbon sequestration, carbon sequestration and utilization. Carbon capture, sequestration, and utilization, CCSU. Anyway, yeah, that's working, but it's a tiny, tiny, tiny amount of what we need to do. Direct air capture is, you're talking about 412 parts per million in the atmosphere. And you're pulling that out in the volume that we're working on is tiny. We're a long way from scale. And the scale you see, we're at 412, we need to pull that out. How are we going to do that? That's a lot of carbon dioxide. And so, yeah, working at it. I mean, a fellow, and I can't remember, I don't know if it's a woman or a man, so I use fellow generically, from Scripps, had a great quote, I thought. We don't have a silver bullet, but we have silver buckshot. So we need to use everything. We can't say, oh, this is the answer. We need everything. So yeah, carbon capture and sequestration. One of the most promising actually is soils, to capture carbon in soils and sequester it. Sure.
Okay, so you have a ton of data in your book, right? You do a lot of analysis yourself. Here's a lot of analysis. Do you use AI, and is it showing to be really effective in these global scenarios to solve problems?
The question is, do we use AI in climate change? I don't, but I'm on the community advisory group for LBNL, and they do. They're building all sorts of new ways to look at things. Interestingly, LBNL, everything they do is related to climate change, one way or another. Interesting, huh? And all of their money-making applied technology projects have come out of basic research. Pretty cool. Okay, one more.
What do you think about geoengineering solutions? Darkening, filling the sky with clouds, or putting curtains in front of the sun, whatever you think of in terms of geoengineering, does that help?
The question is, what do I think of geoengineering, like sending particulates into the stratosphere and cooling? We have no idea what the effect is going to be. We think we have trouble now. You know, we have no idea. It's just very, very dangerous. It's looking into it. Absolutely. Absolutely. Look into it. Let's figure out what we can do, what the possible repercussions of that would be. But that's scary to me. I mean, that's a last resort. I hope we don't have to get there.
To me, that's almost pointless, because the payload of any aeronautical vehicle that can reach great heights is so small that it would be trivial. The amount of material you could put up in the atmosphere would be trivial.
His comment is the amount of material you could put into the stratosphere is small relative to the amount we would need. Again, scaling. One last question. Yeah.
Your talk titles about tipping points, possible tipping points. Which is the most urgent tipping point?
Permafrost. No question in my mind. It's already happening. It's totally irreversible, and it's enormous.
Thank you so much.
You're welcome.
Appreciate it.